Hi, it's Andy from Grade Up Physics. Now today we're going to follow on from some of our work we've done recently on rearranging formulae. Today we're going to have a look at some of the more complicated ones that we see at GCSE Physics. These are our kinetic energy and elastic potential energy formulae. So let's dive straight in. So we're going to start off with our kinetic energy formula and have a look at trying to rearrange this here. So in a previous video we had a look at the 5-step plan. It's our way of dealing with some of these more complicated calculations in a way that's going to get you many more marks and sort of hopefully mean that if you do make mistakes you're still going to get loads of working marks as well. So what we're going to do here, we're going to apply a 5-step plan to this one. It's a bit of a complicated one, so always a good idea to use a 5-step plan. So we start off with writing the formula in the form that we know it, looking a little bit like that. So let's have a little look at our data. That's our next stage. So we've got a kinetic energy of 250 joules and a speed of 5 meters per second. So we're going to start off by dealing with the data and extracting those numbers from our question. So our kinetic energy is 250 joules, our mass is what we're trying to find out, and our speed is 5 meters per second. So we're going to move to step 3, which is substitute. So we'll substitute these values into our formula. So 250 is equal to a half times mass times 5 squared. So at this stage here, it all looks rather scary if we're trying to rearrange this to find mass, but one of the best things that we can do is actually simplify at this stage and actually do a little bit of work before we begin rearrangement. So of course we know 5 squared, that's 25, so a half of 5 squared is going to be 12.5, so I can actually simplify that here. So instead of saying a half times mass times 5 squared, we're going to work out a half of 5 squared, so that's 12.5 times by our mass. And suddenly this now looks an awful lot more straightforward. So if we get our calculator out, again, we've looked at loads of different ways of rearranging this. If you like formula triangles, it's going to look a little bit like this. So as always, our formula triangles start out life a bit like this. Look at the side that's got 2 parts to it, make the formula triangle look like that. So 12.5 times mass, and then our 250 goes above. Cover up the thing we're trying to find. So 250 divided by 12.5 will give us our mass. But of course we can happily use algebra as well. We will divide both sides by 12.5. So we end up with this here, and that equals our mass. And when we do this on our calculator, 250 divided by 12.5 gives us a mass of 20. And of course, final step, add units to our answer. This is mass, so this will be kilograms. So there we go, that's how we can rearrange this for mass. What we'll do now is we're going to move on to having a look at rearranging this formula for velocity. Okay, so let's have a go at trying to rearrange this formula now for speed. So we're going to have to go through exactly the same process as before. So we'll have a go at substituting in, we'll have a go at simplifying, and then that final step of rearranging. So again, in this particular question, always start off, let's write down the formula in the form that we know it. So kinetic energy is a half mv squared. And we're going to then deal with our data. So here are our data points here, kinetic energy 200 joules and a mass of 100 kilograms. So let's deal with our data. So 200 joules, again the appropriate unit. Our mass is 100 kilograms, again the appropriate unit. And then our speed, the thing that we're trying to find out, is unknown. So let's sub in what we know so far. So we know that kinetic energy is 200 joules. That's equal to a half times by 100 times by our speed squared. Now once again what we can do is that we can actually simplify at this step here a little bit. So a half times 100 will be 50, so I can make this thing look a little bit nicer, a bit like this. So let's rearrange as before. Again, we can use our formula triangles if that's what you prefer. Cover up the side with only one thing, so we're left with 50 times by v squared, and then the 200 goes in the top. So 200 over 50 equals v squared, and that's of course going to equal 4. But we haven't finished here. This time what's interesting about our triangle is we haven't got v on its own. This is v squared. So when we've used the triangle this time, we've actually worked out what v squared is rather than v. So we still have one more step that we need to do. Now of course our good old friend the square root is going to come in here. So v squared equals 4. So what that means is if I square root 4, this will give us our v, which is 2 meters per second. So we're going to move on to some elastic potential energy next, but this is going to be a chance where you can have a go at these questions for yourself a little bit. So what I'd recommend right now, perhaps pause the video if any of this has been a little bit quick for you, have a nice slow look through our 2 examples, and then what we'll do is we'll move on to elastic potential energy in a moment. Okay, so we're going to have a go at some calculations involving elastic potential energy now. Now the good news with these ones is that the actual process will feel very, very similar. The elastic potential energy formula is exactly the same format as the kinetic energy formula. So all our little tricks that we use for simplifying and rearranging are going to work for this formula as well. Now what I'd like you guys to do this time is to actually have a go at these yourself. Now you can use our work on kinetic energy as a bit of a guide to help you with these ones. Now I have been a little bit sneaky in here. We always have to check our units. If you notice, I've actually put the extension here in centimetres. So you are going to have to do something with that before you start substituting that into the calculation. So pause the video here. We'll come back in a moment and see how that went. Okay, so I hope that went well. Let's have a quick zip through and see how it went. So as usual, we'll start off with our formula in the form that we know it. So our elastic potential energy is a half times our spring constant times bar extension squared. Let's deal with our data, do this down the left hand side. So our elastic potential energy is 0.25 joules. Our spring constant, that's the thing we're trying to find out, and our extension from the question is 5 centimetres, but I'm sure you realised we've got to convert this into metres. Centimetres is not the SI unit for extension. Like with any length, we have to put this into metres. So 5 centimetres will be 0.05 of a metre. So let's sub in. So 0.25, our elastic potential energy, is a half times K times by our extension squared. Now this is the point where we saw last time. We can simplify this a little bit. So on my calculator, I'm going to do a half times by 0.05 squared, just so we can simplify the side of this a little bit. So we've got 0.25 is equal to 1.25 times 10 to the minus 3 times by k. So it's looking a little bit nicer now. Don't worry, we've got non-standard form here, we've got standard form here. It doesn't matter. Your calculator is going to do this fine on the next step. So using the algebra approach, I'm going to divide both sides by 1.25 times 10 to the minus 3. So it looks a little bit like this, and that will be our spring constant. So 0.25 divided by 1.25 to the exponential minus 3 gives us a spring constant of 200 newtons per metre. So I hope that went well. What we'll do now is that we'll move on to question 4. So I'm just going to move my bit of paper up so we can see question 4. Okay. So once again, what I'd recommend, pause the video there and then have a go at this for yourself, and we'll go through this together in a moment. Okay, on to the last one then. So just like before, let's work through this problem using our 5-step plan. So there's a formula in the form that we know it. We're then going to deal with our data. So here is our elastic potential energy, so 0.125 joules. Our spring constant, you can see here, is 100 newtons per metre. And then our extension is the thing that we're trying to find out. So let's substitute in now. We don't have to worry about units, everything's fine. So 0.125 is equal to a half times by 100 times by e squared, our extension. And again, this is where we're going to simplify slightly. So of course, a half times 100 is 50 times by e squared. So I use the triangle for this one. It's always nice to mix it up. Again, it doesn't matter what approach you use to rearrange, as long as you're confident, that's the important thing. So again, let's have a look on the right hand side, because I've got 2 bits here. Make the formula look like this. So 50 times e squared, and then our 0.125 goes on top. So to work out e squared, it'll be 0.125 divided by 50. And let's just bring the calculator over to work that out. So 0.125 divided by 50, and that gives us 2.5 times 10 to the minus 3. Now if you remember from last time, what we saw is that this isn't e, this is not our extension, this is e squared. So we've got one more step that we have to do here, in that I'm going to have to use the square root to actually work out what e squared is. So our final step is that we're going to do the square root of 2.5 times 10 to the minus 3, square root of 2.5 times 10 to the minus 3, and that gives us our extension, which is 0.05 metres. Okay, so I hope those questions went well for you. Now, like we say, this is very much a sort of tried and tested approach. This whole idea of simplifying before you start rearranging, hopefully, is going to solve some of these kind of trickier issues that you might have with rearrangement. And what we're trying to do every single time is to try and rearrange this in an easy way as possible. And so what you find, that simplification step just makes this an awful lot easier. So as always, I hope this has been a useful video for you. Please do have a look at some of the other videos on the channel, and as always, in the comments below, if you've got anything that you're interested in, anything you're finding difficult, please do request. And as always, like and subscribe for more how-to videos. See you soon.